Hello everyone, myself Kalachelvi, Assistant Professor in the Department of Mechatronics Engineering, SNS College of Technology. So today we are going to see about the topic up-down counters. So in sequential circuits, so from the design of digital circuits. Okay, so let's move on to the topic. Before going to that up-down counter, we know about what is meant by counters in your digital logic. Okay, so in digital logic or digital circuit, a sequential circuit that is used to count pulses is called as counter. Okay, so counter is nothing but it is a device which stores the number of times particular event or a process has occurred, often in a relation, so for a particular signal. So counters are used in digital electronics for counting purpose. They can count specific event happening in the circuit. Okay, so a counter is a set of flip-flops including an applied clock signal, and this is the broad applications of flip-flops. So these are designed as separate IC, application specific ICs, integrated circuits, to use extensively in digital circuits and also in a larger ICs. So counters are available in different types, like asynchronous counter, another one is synchronous counter. So asynchronous counter is does not use the universal clock, so only first flip flop is driven by the main clock, and then the clock input of rest of the following flip flop is driven by the output of previous flip flops. So this is called as asynchronous counters. And then synchronous counter, which is nothing but it has only one global clock which drives each flip flop in a parallel manner, so the output changes in parallel. Okay, so this is about counters. Okay, so we have to design up down counter, right? So here it is the empathy part. So first we have to understand the need of that up down counter. Okay, so in many real world systems counting is not always one directional. We often need both, right? So increase the values like up counting, like floor numbers in elevators 1 2 3 4 likewise, and then decrease values down counting like countdown timers, and then track the position forward and backward like the motors and the stepper motors are robot likewise, and then adjust the scores levels are setting both the ways. So these are all the points we have to look out for designing the counter. Okay, so just like a volume button that can increase or decrease the sound in your car or in your radio, like that, circuits need a counter that can move upward or downward based on the user or system input. Okay, so this is our customer need. We take it as a empathy for the up down counter. So those our solution, we have to made a up down counter for this need. So this is up counter. So here we have 4-bit synchronous up counters. So we are using the JK flip flop. So the first flip flop is toggled on every clock pulse. Okay. So the second one is this is toggles only if the Q naught is high. If the Q naught is high, the second flip flop will toggle. Okay, and then the third flip flop is toggle only the q0 and q1 both are high, and then final flip flop is toggle only the q0 q1 q2 all three the flip flop is high. So this is likewise the up counter counts the values. Okay, and then down counter, it has the 4-bit synchronous down counter. It is also used the JK flip flop. So here we have the clock pulse. So this is a synchronous type. So every flip flop having the clock pulse at the same time. Okay, the first one is flip flop toggles on every clock pulse, and then this flip flop toggles only if Q naught bar is high. So we consider the inverted output is high to the next flip flop. Okay, so third one is if Q naught bar and then Q1 bar both are high, means the third flip flop will toggle. So same lies Q0 bar, Q1 bar, Q2 bar, all the three first three flip flops are high. then only the fourth flip-flop will toggle. Okay, so likewise the down counter will work. The down counter counts the values as like 9, 8, 7, 6 likewise. Okay, so this is about the up counter and then down counter. Okay, so we know what is mean by up down counter. So the up down counter is also known as the bidirectional counter. So this counter used to count in any direction based on the condition of the input control pin. So these are used in the different applications to count up from 0 to provide a change within the output condition on attaining a fixed value, and other count down from the fixed value to 0, so to give an output condition change. So these are some type of counters like we have the IC numbers like 74LS190 and then 75LS191. This like these are all the example for up down counter. Okay, so here we have the 4-bit synchronous up down counter are here. It will work both the up counting, it will perform the up counting as well as down counting. Okay, so this up down counter operation can be controlled through the control input of up down. We have up or up bar, down bar. Okay, okay, this is the control pin. Based on this control pin it will operate. This up down counter works in two modes like count mode, I mean count up mode and then count down mode. So here also we are using the JK flip flop. Okay, so in up counter it starts counting from low to high, whereas in a down counter it starts counting from high to low. Okay, so in the up counter every flip flop activated through a normal output of the previous flip flop. Okay, and then in a down counter the first flip flop is connected to logic 1, then it will toggle for each falling edge. Okay, so likewise other flip flops are working. Okay, so it has the many features, and then this up down counter having the up counting and then down counting, right? So this up counting uh, have the count events in the increasing order, the down counter counts the events in decreasing order. The main advantages of this up down counter is okay, the main advantages of this up down counter is can be cascaded with the high speed mode, and then it can be synchronously incremented or decremented based on the clock transition from the low to high. These counters are very easily designed with the flip flop. Okay, so the main disadvantage is not widely used because they are inaccurate at high clock speed. So that's why we are not using this up down counter for a particular application. So it is mainly used in the asynchronous decade counter design and then clock divider circuits, and this type of counters also used in the car parking slot also. Okay, so these are the main applications. And okay, so these are the reference for this counter circuit. Okay, okay, so this is our up down counter. Okay, thank you.